Well, hi, and welcome to my shop here on February 27th. So the last video I posted was about tube testing, and since that video I have rummaged high and low for a replacement for this very weak tube here, which is probably responsible for the low audio output in this receiver. And no, I don't have one. That's very disappointing, but it caused me to clean up my tube collection further. So time well spent, but no time spent on this, except I did come up with a couple of tubes we're going to take a look at. What I'm going to be doing today on this radio is starting the capacitor replacement process. Probably focused on the audio end of things to start with. But in the meantime, here's a couple interesting tubes. If you've ever wondered what a bad tube looks like, one way a tube can go bad is to leak air inside. And when it does, the getter inside turns white like this. So this is a tube with a crack somewhere on it. It's not obvious. Often it's quite obvious. The top is broken off. There's a crack right in it, or a crack through the base. There's nothing obvious on this tube. But there can be no question. There's air inside here. And it's caused the getter to completely react, probably with oxygen. I mean, what else would it be reacting with? Certainly not nitrogen. And that's what you get. So this tube, no good. And what kind is it? 6AQ5, 6AQ8. Oh well, that's gone. And here's another tube that's worth looking at. I think I mentioned tubes with a black material that builds up on the inside of the glass. Isn't that a very unusual shape to it? Wispy. Looks like it's windy in there. How did it get like that? So just behind where the black is, there is a hole in the let me just move the camera here a little bit, get a little better lighting. There's a hole in the plate. Likewise on the other side, there's a hole in the plate. Now you can just imagine that there's something blowing out of that hole, like a wind blowing out. And the particles there, you can see they're a little better. It's a very odd looking thing, isn't it? It's not really a hole, it's a flap. And they've cut the metal open on, you know, three sides of a rectangle and then folded it up a little bit. That's unusual. So why those holes are there, I don't know. Look at the black stuff. Doesn't that suggest that this is a high mileage tube? But this tube tests okay. It doesn't test like new, that's for sure. But it tests okay. It's not it's not ready to be thrown asunder. And what tube is it? You know what? This could have. Oh, I think it says 50C5. I think that's a 50C5 output tube. Runs hot, but still good. But anyway, I look for that black material, and I've been using it as a judge on how many miles are on these tubes. This would be high mileage, but like I said, it still tests good. Maybe I'm wrong about that. Could be wrong about a lot of things. Okay, so now let's take a look at this radio here. There's lots of capacitors. Most of them are going to be a little difficult to get at. A little difficult. Should we go for the toughies? I usually like to do the tough ones first and leave the easier guys for later. So there's quite a few on this board. A couple right down in here. Can't even see where I'm pointing. And those might be some of the most difficult. Maybe my goal today is to do the capacitors on this board. One possibility is to pull that board out of there. We saw before that, well, we didn't. Let's take a look at how is it attached underneath. Let's take a look. How am I going to do that? How did I have this upside down before? Oh, I know, I had it tilted on its face. Let's get this off of here. Wouldn't normally tilt up a radio like this, but this one gets relatively steady. So here's the bottom of the board right there. How's it held in there? Very mysterious. Okay, so there. I see right here. You probably can't see this on camera. Well, you can see that little bit of shiny metal there. That's a tab that's come up from underneath and has been twisted to lock the board in. One twisted tab there. And where is there another one? There must be more. There, I remember seeing this. Here's the other one. Is that it? Just these two? So the thing about these twisted tabs is you can untwist them, but if you go to twist them back, they may break right off. You may only get one shot at it. So twisting these and removing the board may result in not being able to put the board back and make it steady without some even further engineering finesse on it. It's just those two. Is that right? No, it's just those two. It'd make it so much better if I could get the board out of there now. There's wires that are going to restrict it. You know, my guess is board was built with components, then placed on here, and then wired. And the wires won't have any slack in them. So getting the board out. So it looks like we have wires down this side. You could take the board and rotate it upwards. There's something going on over here. There's a pile, there's a cable underneath this big one. There's another similar cable, this one here. Just coming along, and then the wires come out and they attach to this board. And most of them seem to attach over this way, so maybe you could still rotate it upwards. I suspect there's more to this. It's going to make it essentially impossible. There's a green wire down here. Okay, so what about doing the work with the board still in place? So can I get my soldering iron down the back here? Not all the way. The lowest capacitor, I'd have to reach is down here. Get my finger on it. Helps me figure out where it is on the other side. Well, right on the limit. I did say this was the more difficult ones. Now I could release wires, get the board right out, put the board back in and reattach the wires. The more you do, the more risk you take. But I don't see any other real angle on this. Suppose I could loosen these two tabs, get the board loose, and then by moving it figure out what to do about the wires. I can do the minimum wiring. One of those wires seems to have a fair bit of slack in it, this yellow one. Maybe pulling this cable loose here. There's another wire there. Wow. It's a lot of stuff to get right again. And I know myself. I make mistakes doing this kind of thing. Things always look easier at the start. They get more difficult as you go. Okay, you know what it is? It's time to stop for a few minutes. Let my brain cells discuss this situation while I drink coffee. And then we'll see what my brain cells have to say after that. Okay, I've taken about a dozen photographs of this board, try to get every angle on it, so whatever I do here I can undo. So let's just go over what I've determined. So I'm going to try to twist these tabs, the two of them, until they're just enough to go through the board and no more, just the minimum to get them through the board. Some of these wires I can disconnect from the board easily, like this orange one, quite obviously. The best strategy is to disconnect it from here and then try to leave it hanging in its appropriate position, but these are nicely colored and identified wires. Get down a little further, it gets a little more difficult to remove the wire from the board. So each wire I have to consider, should I take it off the board or can I remove it from another location? Like for instance, let me just get a hook here. So this yellow wire here, this one, it goes, where does it go? There. So I think it's probably, well, I don't know. It's difficult at either end on that one. But I have options here of which end to disconnect. The tough ones are these guys down here. Kind of go in the middle of the board. Those two guys, as it turns out, if I lift this up here, I have to use two hands on the chassis to do this safely. Don't fall, camera. So down here, we have these orange and black wires coming here. There's a pair, an orange and black pair. And what I've done is I've realized, well, they're easily removed from down here. And then I've identified one by marking it. This is the upper pair, or the length of the wire, and if I try not to bend them too much once they're out, they should kind of fall back in place. Is that a little piece of solder there? Not exactly. So I think I'm ready. First one to try to twist is this difficult to get to tab down here. That's where I'm going to start. Can we twist those tabs? If I can't twist the tabs, whole plan is off. So I have to kind of come down from above. There's no slack in most of these wires. So now I'm moving things from where I took the photograph. Okay, I think I can go right down on that. Maybe it's inevitable that there's a way to do this, because somehow they did it when they first built it. Okay, there's a chance this is going to break off, but you know what, I can always glue stuff later if this is what happens. Oh, this is a tough one. This is stronger than my pliers here. Oh my gosh, these are really, really hard. Holy smokes, I didn't figure on that. Holy smokes. My pliers are not good enough for that. Oh, man alive. You can get something like this in there. Oh my gosh. What the heck is going to go in there? Channel locks. Uh-oh. Bigger alignments, tools here. Nah. Oh my gosh, this is really I have to think of another alternative already. Let's try this again. pliers. I think I twisted it a bit. That's a good sign. What else have I got here that might be able to tolerate it? Maybe these are a little stronger. They're shorter. Ooh, something snapping. Okay, I think I got that one enough. Get the board out. You know what? It's bent over this way now. That's because my tool is going in on an angle. Sounds like something you'd say to your first girlfriend. Ugh. Okay, that one's that. I know where that one is. Let's just... I have to keep one hand on the chassis the whole time I'm doing it. When it's up like this, it's not stable. Down you come. Okay, top one, I got a lot more opportunity here. So the thing about this metal, the kind of metal here, steel basically is what this is that if you bend a piece of metal far enough, you can bend a piece of metal so far when you let go it springs back to exactly where it was. That's called stressing the metal. You haven't actually changed the arrangement of the atoms in the metal. But if you move it far enough that when you let go it does not come all the way back, then you've strained the metal and you've caused a relocation of some of the atoms. It's not coming back. It's something different now. This guy, just twisting it the first time, does all that strain. It's terribly weakened. Watch your fingers there. If you use pliers like this, you know how they can bite you, right? When do accidents happen? Accidents need a number of things. They need energy, and I can't remember the rest. The energy is the interesting one for me right now. The energy is me squeezing hard on this tool and really giving it a heave-ho. That's high energy, high possibility of injury to me or to this radio. Oh, even this one's twisting a little bit. Okay, you got it? Pretty close. Looks like I gotta bend this part up. Come at it this way. Looks like I can. Get my best leverage here. You know, things can happen when you're busy looking at the business end of your tool. The other end is jamming into stuff and knocking things out. You don't see it. Now, you might see it on the video because you're free to look everywhere. But I have to watch what's. I mean, this is natural, right? You look at the action point. You're not letting your eyes wander all over the place. I'm not, like you could. Okay, I think we got that as far as it can go. Now, what problems are we getting into now? How come it wants to spring back like that? Is there something more holding it? Just all the wires pushing on it? You think it would come forward and kind of stay forward if it's loose. Well, it could just be all these wires. So I'm going to start de-wiring them now. I see this string is right here where my soldering iron can touch it. One little touch, I'll be in tears. I think we should get this string out of here. The thing is, if you like remove a string from a pulley, you're one step away from disaster on that. So I'd want to hang it somewhere. I wonder if I can hang it on this. Just stretch it. Let's see, it runs to the spring over here. How much spring is it? Oh, a fair bit. So maybe I can get it and just hook it over here, and it can stay there. It's a bit of a sharp edge. A bit of a sharp edge. Let's see if I can unsharpen it quickly. I'll look for some tape. Where'd my tape go? Oh, my good tape. We do not want to damage these strings, because, you know, so there's a term that's used, at least where I used to work at a power company, the lineman used a term called a jackpot. And a jackpot is a situation that you don't want to get into, because when you're in it, there's no way out of it without something bad happening. Usually it involves an injury. Okay. So I don't want to get into a jackpot here, so I'm going to pull off the tension a little bit, grab the string. It should give me more play. Can you get there? Okay, you got there. Hurt it with this tool. There. Okay, so that moves this string back, because one tap with the soldering iron and I'm putting a new string on it. And I don't want to do that. So we'll detach what wires we can. They're easily reattached here. These are pretty close too. They're in this nice plastic tube. Some of these wires go into a cable. There's no other end to remove. My options here too are to, oh, look at that. Wow. So this yellow wire is on a lug, and a lower yellow wire is going through the board and is soldered on the other side. Is it even accessible? It is, but wow. These are a bad task. Now my plan was to pull this forward and rotate it upwards and leave most of these connections in. So why am I even bothering with these? There's a black wire at the back here. This black one. Where's it going? It's got a shield on it here. I have to remove that one, I think. Maybe not. Maybe not even remove that. It's this yellow one down here that's really the problem. Okay, let's go underneath. It's low, so I'm trying to assess the risk of every move, and I'm trying to do these in the least risky way forward, because again, I'm trying to stay away from the jackpot. The jackpot in this case would be getting 3/4 of the way through this and then realizing, oh, this can't be done. That would be quite the jackpot right there. So I'm going to remove these wires. And then the one that coming down from above. It's a yellow wire. It's a yellow wire. It's this wire here. Why do I care about that one? I don't. It's not attached to the board. Okay, so if I take these 4 off, what am I gonna do? I can take them off here. There's a white one here, but that might be able to. I might be able to just lift the board upwards after that. How loose is it again? It's gonna be problematic getting it off these tabs. Oh boy. If I just leave the wires, try to get it off the tabs. If I can't get it off the tabs, it's game over. Or at least this approach is over. I really do have to get this board out. I can't. Well, that's a good looking capacitor, but if I need to change that, I can't do it with it in here. This board has to come out. Hot dog. This tab is still bent over. Can't really whack it with a hammer. That would not be a good idea, but that would bend it. I need some kind of cockeyed tool. I don't have one. I can get in there, bend that upwards. Hey, wait, maybe the channel locks. They're a little cockeyed. No, there's no room for them to get in and do this. Yeah, it was a cockeyed idea. Oh my gosh, it's time for more thinking. Not really. I got something that can go down, fit on there, and then jam it up. It has to be so strong. It has to be small and strong at the same time. How can that be? Okay, I'll try some controlled heaving on it here. Maybe I'm wrong about how hard this metal is to bend. So here's another case where I'm going to put a lot of pressure on this tool and jam it in here really hard, and if it slips, what's it going to do? It's going to make me cry, that's what it's going to do. And I think, you know what, if I push hard enough, this whole thing's going to kick out from underneath and fall. Let me put this over a little bit more like that. Just trying to envision what can go wrong. And as much as I can. So I can avoid it. Trying to select how I'm going to mess this up. Be selective. It's not working at all. So I get it off one tab, I can work it off the other. If I get one tab straight, then I should be able to. Yeah, this is the one. This is the one to get it off first. Yeah, there's a first and second to this. Good. Let's see if we can just straighten this part out here. Okay, it's going to come off. It's still just as tight as can be. This board is hung up on things I'm not thinking about. For instance, I'm not thinking about this. There's this cable, the one behind the yellow one here. This one, it comes down under, and then it goes right across. All the wires coming out of it are tying here. You know what? These are pairs. This is a yellow and orange pair, and this is a yellow and orange pair here. I'm going to mark one of those. Mark the upper pair. The upper pair. I just have to mark the orange one here. Pair of wires. What are the chances I can go way back at the other end of this cable? No, I was going to say remove the whole cable. Oh, man, that's too much. That's not a good option here. So the problem is these wires are right in front of the board. So if I move the board this way, I won't have any freedom of movement because of those wires. And they're not about to be disconnected. They go through the board. So the objective would be to rotate this up through all this just by working it. Don't have to worry about this yellow wire now. I realize it's not part of the game. The lower down wires underneath would be free. But as for getting this board free up here, and then that allows me to make a lot of movement to get it free down below, that's not true. There's not a lot of movement in this thing. You know, it's really caught on that cable. Why don't I just loosen these cables off? Well, this one's jammed in here. Jammed really tight. Get the light out of the way and see what we've got underneath there. Get the light out of the way. Oh my gosh. Isn't this just slid on? I'm sure it's just slid on. It's just slid on really good. Try getting that light bulb out again. So, you know, I could crack this right now, trying to get this bulb out. And I've got more hassles. More and more hassles. Here. How can I get that out of there? Let's give it a grab with this. No grabbing. What about a tap? Where to swing a hammer. Wow. Do I really have to get this off here? Maybe not. So I know it's just a bundle of wires between here and here. It's like having a metal pipe in there. Even if I get this off, there's a metal tab sticking out doing the same thing. So I don't think there's much advantage to getting this off, come to think of it. So I gotta get in there and force, but there's no play in these wires. How about disconnecting this cable? It's many wires inside, going all over the place. So it's really the one underneath that's causing the problems. So there's some orange and yellow wire in there, coming from the little cable. Let's see how much of that I can move. Move quite a bit of it. This is where the kind of the two cables are squeezing this thing and holding it. I can get one loose, loosened up. There's a little bit of slack up here. Okay, that's better. Get this off. On the big yellow tube there. See, this is what electronics looks like. Got the right tool here. Need something bigger and badder. Okay, that's out of the way now. How much play have we got now? Okay, it's still catching up here. So this black one back here is tight, but not holding this. Okay, let's bend this down a little bit. Still got a touch of a twist in it. I don't think that made much difference. There it is. Okay, so it's off at the top. There's no... There's another whole approach to this, and that's to take this plate off. No, that's not going to happen. Then this bracket is screwed to this plate. To get at those screws, you have to take this off. That's a big job in itself. just assessing it here. Knob's got to come off. And loosen off these gripping brackets here that are holding the glass. Allow the glass to come off. You have to deal with this tube, which is strapped to a plate, which oh no, it's not on the glass. It's just pushed up against the glass, so this would stay. You don't have a way to get a screwdriver in except this paper's in the way a little bit. It can be slid a little bit. Probably do it at that point. And this bracket disconnected, now what? Not much different than where I'm going right now. So I get the bottom off. I'm starting to realize, here's the jackpot. Yeah, you can't just twist this and get it out of there because there's just no room for the twist to happen. So I moved the board this way. It's making the bottom of it more accessible in here. I have to get all the way down to this capacitor here, which is just wow. It's down there. How much farther forward? If I can get this board to come farther forward, I'm doing well. Okay, to get it to come forward more, I have to increase the clearance where these wires are. And unfortunately, the plastic pipe was coming right over here too, which is just adding to it all. This is where something goes crack. It's easy to underestimate the amount of leverage you're putting on things when you use tools like this. All I'm thinking about is just, you're going to get into trouble. You're going to get into trouble. You're on your way to disaster. Disaster is looming. Wow, thing came really loose there, didn't it? Okay, so now what's stopping it from coming even further forward? One thing is this black wire. There's a white wire down there too. It's got more slack. But you know what? This is not stopping it. There's enough slackage there. It's not stopping it, but it's pulling on it. Put its brother down. Now, why won't this side come so far forward? You know what? This is getting more and more possible to do here. If I can just wiggle this board back and forth. And push it up. Glue on the front. Push it down. Solder on the back. Maybe I'll take these two wires out of here. That's easy. Okay, so where are we at now? So I can do these two that way, and I can probably get down to doing these. We still have down on the bottom. Now, the bottom had a couple of capacitors look pretty good. What's going on with my tripod's giving up the ghost here? One leg. No, don't fall over, tripod. Last time you did that. I'm gonna have to fix my camera afterwards. By the way, you're looking through the camera. What's going on here? There. One leg on my tripod's trying to collapse in the middle of this. Yeah, a couple videos ago I dropped this camera on the floor. I used a little bit of glue to get it back in shape. This is pretty exciting stuff, eh? Okay, now we're going to look underneath and assess the capacitor access underneath at this point, because maybe I'm there. It's like you're on vacation. You're driving to your vacation location. Stop overnight somewhere short of where your goal and decide, hey, this is just as good as going all the way. Why go all the way? So these guys are tough. But these are, actually much more reliable capacitors. I can actually leave these in, certainly for now. The radio does work to some degree. The problem with the radio is probably related to the weak tube and other capacitors, like these guys here. Why would I go after those? So maybe that's it. Maybe I've hit the mark here on this. I figured it all out, how to do this successfully. I get rid of 1, 2, 3, 4, 5, 6 of these ugly, crummy capacitors. And call it quits at that point, unless there's a strong indication that these other capacitors need to be changed. I kind of doubt it, because I mean, look, with the tube gone, you can see a whole collection of crap capacitors in here. These are the guys who are causing performance issues, if anything. And I actually have to do all these capacitors before determining if anything else is out of sorts. That's it. That's it. That's the plan. The plan is do these guys up here and leave this board in a floppy state. And after doing that, play the radio, see if it works. And what is this board anyway? What's the function of it? It almost looks like an additional thing. In this model, this additional board is put in, but I kind of doubt that. It's hooked up to the volume, and there's some wires going to the volume. Now they're going here to the output transformer too. Well, it's probably part of the audio circuit because it's right here at this end where the audio stuff is, including the bad tube. Okay, more copy, and then we start the surgery. Oh my God, that took half an hour just planning it. So the rule of planning, by the way, let's say you've got 6 hours to get something done. Well, 6 hours. 6 hours to get something done. You should use a quarter of that time to plan what you're going to do with the other 3/4. That sounds ridiculous, doesn't it? But what you're trying to do is you're trying to do just what I'm trying to do here. Not get yourself into a jackpot. It requires forethought and planning. And flexibility. And most importantly of all, luck and coffee. Okay, so I've downloaded the service manual, and in it is this page with this diagram. And that's the board I'm working on. These are the capacitors I'm aiming for now, these guys. These ones down here look like much more reliable capacitors. Maybe not so much in the photograph. But look at the name of this board. The volume tone printed board. So the deal with this is perhaps one of these capacitors is what's sucking the volume out of this radio. So that's just possible. So that's a good thing. By the way, this is a very extensive schematic. Let me just show you the pages here. So across the bottom of the screen you see not all the pages, but most of the pages. I can't point at them or they'll disappear, but the three on the left, let's say the three on the right, are obviously images of the boards and stuff like that. That's really helpful with the different components identified and numbered and all that kind of stuff, just like the one you see on the screen. And then to the left are 3 pages of schematic. 3 pages of schematic. Yeah. Okay, so I'm very much encouraged now with all this kind of stuff. I'm going to go ahead and change out these capacitors, and we'll see what happens if I've ruined the radio yet. Okay, I've decided to capture on video the removal of one of these big capacitors here. I just grab the lead like that. I can lever against the board. Let's see if we can get it out. There. Now that makes it easier. The next part, just to get it out from below. There we go. goes. Ta-da! 0.1. 250 volts DC, good for 100 AC. Okay, I'm going to put this on the tube. Put this on the capacitor checker. This is the first capacitor to come out of this. So certainly the first few capacitors need to be tested in order to judge their condition. That's just, I expect this to be bad. Bad would mean you can't take 150 volts and open this eye. So the way this guy works, the way I'm going to use it, is it applies a DC voltage to the capacitor, and then the eye is sensitive to the amount of current that's leaking through the capacitor. Good capacitor, no leak. Bad capacitor, leak. If it leaks, the eye stays closed. It's open right now at the bottom. When I first hit the switch, the eye will close momentarily while the capacitor charges because there's a current flow. But it should stop fairly quickly. Here we go. It's opening, it's opening, it's opening almost all the way. That's 50 volts. Pretty close to all the way. Here we go. This is the big test. 150. Give it some time now. It has not opened the eye at all. Good capacitor, you can put this up to 450 volts and the eye will open. Well, it depends on the size of the capacitor, how quickly it happens, but the eye will open all the way on a brand new capacitor. So this is typical of old capacitors in these radios. This would rank as certainly not the worst, but bad enough. Could this affect the circuit with the current leaking through it? Depends where it is in the circuit. Depends what its job is. It may or may not be a significant factor. Okay, I'm going to get the other guy out of there and carry on. Should I take out one small one? Why don't I take out one small one and we'll try that. We'll try this top one here. Get it out. Ooh, watch the string. I almost put the soldering iron on the string. Come on out. Come on. You can do it. Not like that. Try to pry it out. This might ruin the capacitor doing this. There we go. Came out pretty easy. And what about this other one? Other end. Watch the string. I gotta protect the string. I'm gonna end up burning it. I keep doing it like this. Wow. Well, that's the end of that capacitor. It did not survive the extraction operation. Get my other wires here. Wreck. All right, there it is. Oh, I touched the string. Oh man. Da, 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 da. This arrangement's not good enough. A little bit of superficial damage there. Okay, what if I unhook the string from here and just leave it laying floppy and worry about it later? I have the restringing instructions, so I'm going to do that because I can't afford to be there. Just stay like so. Don't go anywhere. Oh, I see. So close to breaking that string there. Yikes! that's a jackpot. That's the jackpot. Okay, well, we can't test this. I think I'm just going to carry on my own, get all these done. And oh, wish me luck. Oh, here comes a cat too. Perfect timing. Okay, I got 3 of them out without ripping them apart. Let's put these guys to the test. Now, of course, taking them out is rugged, pretty rugged treatment, mistreatment, abuse if you like. Heating them up's not so good for them. So what we're going to get here, is it really reflective of the condition of the capacitor when it was sitting there? Your guess is as good as mine. My guess is yes. Okay, so watching the eye. Comes up, 150. Opening up part way at 150. These are not the worst capacitors in the world. volts, 150. Look at that one's actually not that bad. The rating is 250. It even opens a bit on 250. Oh boy, oh boy. There's no way to know the condition of these without doing this kind of thing. This is what keeps me honest here. Okay, here we go. Open right up. Opening up part way at 150, 250. And opening up a squeak. Well, they're not as bad as I expected, frankly, but they're certainly not like new. Like I said, if I put a new capacitor here, 450, this thing opens right up. So, are these guys causing all these problems of low volume? Probably not, actually. It's probably this tube. Okay, we get the last capacitor out, and then I'm going to be struggling away here for a long time putting in the new capacitors. This is going to be very, very difficult. Okay, got the last one out. In one, let's give it a go. See what the story is. $50. Okay, about halfway, 150. Not going to open. Okay, well, you know, if these weren't so bad, I think they are bad enough to deteriorate the performance of the radio in some way. This is the tone and volume board, so the two options are not as much volume as you'd want, tone is off. That would be the two problems there. I did manage to pull out a resistor by accident down here too, which is just another additional headache. Okay, I am doing the toughest ones first though. Okay, you can see I've been trying to figure out which type of capacitor to put in, just in terms of what's easier to put in. Any one of these will do the trick. And I have even more in here that would do the trick, but which ones are the ones that are going to go in there the easiest? And the next problem is not only are these long, that's a problem. If I cut them shorter, I need them the right distance apart. I need them to match up the holes. So let's just take a look at the holes. Now, see that yellow wire down near the bottom center of the screen, and right to the left of it is a hole? That's one hole. And the matching one is off to the right in the dark. Another problem here is these holes may be blocked with solder, so putting a wire through it may not be as easy as I might have thought. Let me just use the capacitor here, just use the wires and take a look. These are a little too close together, but I want to do this with a I have to do this again and again, so we're going to use this guy here. I'm going to try to line it up with the holes. much easier said than done. So this is just about exactly correct in terms of width. Okay, that's good. There's the width. So I need to set the wires that wide. Cut them shorter and set them that wide. Just looking at how to do that. And then stick it in there. Okay, I realized I can buy a little bit of space if I pop out the magic eye tube here. Yeah, just pop it out. Just pop it out. And I can move this cable out of the way. What's that? Come off there. That's the protector, so I guess the metal spring that's holding it isn't right up against the glass. I guess is the idea. I'm going to bend this guy right down here. Get out of the way. That tube doesn't even work. Okay, a little more clearance now. Boy, oh boy, it's still really, really tough. Still really tough to see in there. Okay, so I've got this trimmed. It's probably just a little bit too close. Good enough though. How am I going to get it in the hole? I can't even see it. Can't even see the hole. How am I going to do that? Okay, first attempt. I'm going to try to do the easier leg first. It's not easy to work against a camera. Okay, so we're above that resistor and right in this area. Here we go. Go in, go in, go in, go in, go in. So it's probably solder blocked. Okay, soldering iron's gone to sleep here. Let's wake him up. Okay, he's ready for action. Now, hopefully I'm just going to melt this right piece of solder and it's going to go through. I'm losing grip. I lost grip on it. Using the camera is not terribly helpful. Oh, I'm going to drop it again. Got some rosin on my fingers. Okay, whoop, almost got it in the hole. Isn't that the hole? Not the hole. The hole. What is the hole? The hole is not the one right beside. No, it's the one. It's right beside the yellow wire. It's the one over to the left, a little further. Whoa. Okay, stay put. What do I do with the capacitor now? They're way over here. What's it doing way over there? Okay, let's go with the pliers again. Okay, now what? Now we gotta get a grip on it and keep pushing it at the board. Stay in the hole. Nope, the backside. Push it through. Come on. You can do it. There it goes. Now, is that really the right hole? Yeah, I can see the rest up above. Many holes to pick from up there. That's the next capacitor. Okay, now this one's gone in on a bit of an angle, so the other lead is no longer really near where we need it to go. So let me get a grip on it. What's happening is the radio is rotating around on my turntable, and the camera cord is pulling the camera in and out of where I want it. I think I'm way above the hole here. Hole, keep the pressure on. Okay, try to melt the backside. Oh, I've got the board pushed up against it. Pull the board down. Good luck to me here. Oh my gosh. Way down there. Way down here. What are the chances? I can't have a push. I can't push on it. Push on it. I can twist my thumb around like that. Okay, now I can push on it. It's slipping. Don't slip. Oh my gosh. So I'm trying to solder. I'm assuming the hole is blocked with solder. Not going through. I'm getting the right spot. So it should be way down there. Wire out of the way. This black one. Okay, I think I have a clear view of it. Pushing these wires through the holes requires the wire to be lined right up with the hole properly. You can't push it through on an angle. Come on, go through. Go through. Doesn't want to do it. Let me try to straighten out the wire. Okay, that's better. That's now poking straight down into the hole. Okay, come on. Go through. You're melting everything in sight down there. Not getting to the right spot. Oh my gosh. Let's see if we can see with this other camera here. this way. Makes more sense to me now. So I'm going down this row here. Way down there. Looks like there's hardly any solder. Boy, oh boy, oh boy. Is it really in the hole? It's got to be in the hole or it would be sliding around. Pop through. Come on, you can do it. There's nothing else to melt down here. Feels like I soldered it. Why not going through though? What a headache. I'm gonna have hours of video of me trying to do this. Right in the hole. Feels like it's soldered. Do I tug it out? Do I accept it? Tug on it, see if it's really in there. Barely in there. That doesn't look very good. No, it's rattling around in the hole. It did not come through. Now, is that because I'm melting the wrong thing? There isn't a lot down there to melt. So I'm just trying to line everything up. Put some light on the matter. This board pulls a long ways away now. Well, there is a little more solder past that point. Yeah, melting the right solder. Got to apply pressure to the capacitor. Losing my patience. Means I gotta stop. Oh, there it goes. I was on the wrong bit of solder. Okay, that's one in. It got soldered. It's in. Just from the edge of misery to sudden success. It's kind of fun to do in this work. It's a little high, but I think I'm going to leave it like that. Okay, I've met the enemy. They get easier from here. I've done the tough one. Yikes. Well, I'm probably going to call it quits on this video at this point and go answer my phone.